Hello friend, welcome to tutorial series on VLSI design. I am facilitator Ms. Revati Shivkar and my topic is CPLD architecture. CPLD stands for Complex Programmable Logic Device. Name only tells that it is nothing but a PLD. PLDs such as 16V8 and 22V10 have been very efficient, but as technology is changing very fast to adopt these changes, there was a great need of creating still larger PLDs than 16V8. You might have been wondering why didn't they have chosen to scale the existing architecture instead of creating new. To clear your query, let's take an example. Consider scaling of 16V8 PLD to make 128V64. Such device would have 64 input pins, 64 I/O pins and some number of variable product terms, say 8 for each macro cell. The question is, could it be same flexible and efficient as 16V8? Answer is no. Due to capacitance effect leakage current, such a large wired structure would be at least 8 times slower than 16V8. On the other side, what if it tried to connect 8 16V8 keeping number of input and output only 8? That is the idea behind the CPLD, keeping n time logic and n square time much chip area, partitioning a desired function into number of PLD. So simply CPLD is a collection of PLDs on a single chip. This is a general CPLD architecture. Different manufacturers have taken many different approaches to the general architecture, but basic elements of CPLD are I/O block, interconnects and PLDs. PLDs are also called as a function body. So now onwards we are gonna call PLDs as a function block. Architecture elements in which CPLD differs are mainly function bodies and macro cells, but we are going to learn Xilinx 9500 series architecture. These are some of the family members of 9500 family. You can see that they differs in function body and number of macro cells only. So let's see what are the features of XC9500 family. They are available in different packages like VQFP, PLCC, TQFP and so on. So we can choose the IC package as per our requirements, like how much I/O pins we need and cost factor, etc. XC9536 is the smallest CPLD with 2 function block and 36 micro cell, and XC95288, which is the biggest CPLD having 16 function block and 288 micro cell. It is very much clear that CPLD is given name according to their macro cells number. Nextly, very important feature of this family is that each package supports at least 2 different devices. For example, PLCC package supports XC9536 and XC9572, etc. So it is given very much flexibility to the designer. Now let's see what is there inside the CPLD, that is actual architecture of Xilinx 9500 family. This is a typical block diagram of CPLD 9500 family. Each external I/O pins is used as either input-output pin or bidirectional pin. 3 pins which are at the bottom of figure, these are used for special purposes like global clock or global set reset. One of these 3 can be used as GTS, that is global 3-state control. Each functional block programmably receives 36 signals from the switch matrix, and further inputs to the switch matrix are 18 macro cells output from each function block and external input from I/O pins. We can see 18 from function block which runs under the switch matrix and connected to the I/O block. They merely work as output enable signals for the I/O block output driver and used when output is hooked to the I/O pins. Now let's go deep through the major elements of CPLD architecture. First is functional block. As I said before, they are independent PLDs on the CPLD chip. Each functional block contains one programmable AND array, one product term allocator and 18 macrocells. Product term allocator allows a macrocell's unused product term to be used by other nearby macrocell in the same functional block. So even though macrocells have fewer AND term per cell, it do not create any problem because of product term allocator. It is very much clear that XC9500 has 5 AND term per macrocell. So still it can produce large sums of product. In programmable AND array, there are total 90 product terms. How 90? So each functional block has 18 macrocells and each macrocells contain 5 product term per function block. So total 18 into 5, that is 90 product term. This product term flexibility makes CPLD more efficient in area than classic PLDs because typical logical functions need no more than 5 product terms and the architecture supports wider functions when necessary. Now let's move towards input and output block. XC9500's I/O block provides many analog controls in addition to logic ones like output enables. 3 different analog controls are provided. First is slew rate control. The rise and fall time can be set to be fast and slow by this control pin. Second is pull-up resistor. Pull-up resistor prevents output pins from floating when CPLD is powered up. Third is user programmable ground. The feature don't ground the signal pin but they reallocate I/O pin to be a ground pin. Also, this I/O block provides compatibility to both 5V and 3.3V external device. Depending upon the voltage level on external devices, the output driver used either 3.3 or 5V supply. To enable this feature, I/O block uses pull-up resistors and diodes. Now let's have a look on a switch matrix. To explain the switch matrix, let's take an example of XC95108. There are 108 internal macrocell output and 108 external pin input. So 108 plus 108 total 216 signal and those are connected to switch matrix as an input. Also 95108 has 6 functional blocks with 36 input each. So total 36 into 5 equal to 216 output. These 216 output are connected to switch matrix. Switch matrix is a rectangular structure. We can see that in that figure with rows and columns. Rows are for output and columns are for input. There is no necessary to connect each input to each output. There is one disadvantage of this switch matrix. Due to giant structure, it causes high capacitance, so ultimately speed is reduced. So this is the challenge before the CPLD manufacturer to look for a way to maintain the speed. This was all about the architecture of CPLD. Now let's see where this CPLD is actually used. CPLDs are ideal for critical high performance control application. CPLD can be used for digital design which perform bootloader functions. CPLD are generally used for small design. For example, they are used in simple applications such as address decoding. CPLD are often used in cost sensitive battery operated portable application because of its small size and low power usage. So this was all about CPLD. If you have any query, you can go to this link and please don't forget to like us on Facebook. Thank you.